some workability properties. Now we will go to the compressive strength. The testing on the cubes and cylinders depending upon the characteristics of the cement. Suppose the compressive strength generally we will conduct it on the cubes and cylinders as well. Suppose if you are applied the compressive strength, this is the cylinder. Cylinder ka jo height and dia. Okay, this is the dia and height. Okay, the ratio always, that means H is to D, ratio always 2 is to 1. That means, for example, this height is equal to 200 mm, this diameter is always 100 mm. This is normally Indian code prefers. For example, if your diameter of the cylinder is, 150 mm, so the height is obviously 2 times. This is the height. This normally we will follow. Now go to the compressive strength in the UTM or CTM compressive testing machine. Suppose you may test the cubes. Okay, that means cube is 150 mm by 150 mm by 150. Normal size is 150 mm by 150 mm by 150 mm. This is the normal cube, so we have casted for the ordinary concrete and the structural concrete. But in case of the high strength, the same cube size is 100 by 100 by 100 mm. These size of the cubes are casted for the high strength concrete. Suppose in case of the high strength, your machine cannot tolerate that much high strength, so you will go for the smaller size cubes. In case of the structural concrete and normal standard concrete and the structural concrete, that means up to M55 grade concrete, you can go for these cubes. Okay, now I am asking you one question. Suppose I am tested one cylinder. Okay, that means axially loaded. That means in the CTM machine, the load is applied axially. Okay, now this is a cylinder. For example, I will say 300 by 150 mm dia by 300 height, and the same 150 by 150 by 150 cube is obviously I am testing. Okay, this is the size is 150. That means now you can tell me which one is taking the more load and why. The cube strength is more, that means grade of concrete and ingredients are same. Grade of concrete and ingredients are same. But the thing is, while you are tested on the specimen size is different. One is cylinder and other one is cylinder and other one is cube. Okay, obviously the cube strength is more than the cylinder, because this is a slender one. That means its length is more. That means if you see the breaking pattern, after breaking, the pattern is like this, and if you see this, the breaking pattern is like this. So obviously the cube strength is, generally you will get the more strength in case of the concrete cubes. But Indian code prefers the cube is more widely used in India. Some countries generally they will use the cylinders also for the testing of the compressive strength. But normally in India we will follow the cubes only. Now, okay. Characteristics of the cement, that means the factors which are depending upon the compressive strength, influencing factors are the cement characteristics, the characteristics and proportions of the aggregate. Suppose 20 mm size, 40 mm size and 10 mm size, in which proportion you have added, that also depends upon that factors also the compressive strength mainly depends. And degree of compaction, you are properly compacted or not. If you are compacted properly, then the cavities will be reduced. Then obviously your strength will be increased. Efficiency of curing. If your curing is immersed curing, that means you kept the cube under the water, then proper water will be available for entire specimen for the curing purpose. So your curing will be done efficiently. So you will get the good strength. Next, temperature during the curing period. Suppose if you are casted the cube and ingredients are same. Suppose if you take the winter cube and if you take the summer cube, obviously you know the maturity concept well. If you are curing temperature of the water or curing temperature of the air is more, at that time, because of the maturity concept, the strength of the concrete is increased. So the temperature and strength, these two are the directly proportional. If temperature increases, the cube strength also increases. and age of the time of the testing. Suppose if you are tested at 7 days and if you are tested the 28 days, which will give you the more strength? Obviously, 28 days will give you the more strength. The conditions of the test, that means end conditions, what type of conditions you have applied. That means these are also influencing the factors. Next, tensile strength. Generally, normally 10% of the compressive strength is equal to the tensile strength. For example, your cube is M30 cube. For example, 13 Newton per mm square. Normally, the tensile strength is 1/10%. That means 10%. 10% means 3 MPa. That means flexural strength is something different. Flexural strength you have generally tested on the beams. Suppose here I am telling you three stresses. That means first one is compressive. The compressive strength. The compressive strength is generally tested on the cube. That means either 150 mm cube or 100 mm cube. Okay, na? Next, second test is flexural strength. A flexural strength we have casted with the beams. The beams of the 500 mm. That means 0.5 meter length, and that means this is 100 by 100 normally. Okay. Actually, two types of the beams generally we have casted. Second type of the QB beam is 700 by 150 by 150 size, and normally in the high strength cases 100 by 100 into 500 mm. This is normally we will cast it for to test the flexural test. And the third one is split tensile. That means tensile strength, split tensile strength we have to cast it. For this we will test the cylinders. Normally the cylinder size is 300 mm by 300 mm by 150 mm. That means what they will do, suppose this is the cylinder, they will apply the load and the cylinder will broken into two halves. That means this cylinder is broken into two halves. Okay, this is the cylinder is broken into two halves. That means axially, that means if you are applied this cylinder, the load like this axial direction, this in this case it will break into two halves. So if you draw the diagram, initially it was a compressive, but later on it was a tensile, and so ends. This is the actually the stress distribution on the cylinder. This is the stress. This force is nothing but your tensile. This initial case it is a compressive. So generally split tensile, what we have to do, first of all, strictly speaking, for the split tensile, this is your specimen cylinder. You have to apply the axial force like this. You have to apply the axial force like this. But we can't do this. That means you have to apply the axial force on the both direction. But how you can tie up with this cube? That means you can't tie up the cube. Suppose if you, in case of the iron rod, what you are doing? Suppose in case of the UTM mission, this is the jaw. And the UTM mission jaw is there, and the bottom jaw is there. In this bottom two jaws, you will place one iron rod. This is the iron rod. Okay, for example, this is the iron rod. You will fix this iron rod. Okay, this 10 mm rod or 12 mm diameter rod. This is the iron rod. You are fixed between these two jaws of the UTM mission. This is jaw number 1 and this is the jaw number 2. Now you will apply the UTM mission. You will start the UTM mission. What the UTM mission will do? It will pull this iron rod from the bottom, and it will pull the iron rod to the bottom. But after half an hour, what happens? This iron rod is broken into two pieces. That means cup and cone shape. That means like this, it will two pieces. That means you are pulling the load axially in case of the iron. That means in case of the iron rod, steel rod, you are applying the axial force. But in case of the cylinder, in case of the cubes, there is no such arrangement is provided along with the mission. That means there is a problem in the mission. That means you can't apply this cube. You can pull it like this and you can pull it like this. You can't make some pulling arrangement by using the CTM or UTM mission. That means in the UTM mission and UTM mission, jaws are provided in the testing of the iron rods. But in case of the concrete, you don't have that such arrangement. For that purpose, what generally we will consider, we will apply the same cube. Suppose I am drawing this cube in the three-dimensional figure. Suppose this is the 3D. You will apply this force from the like this along this periphery, that means in the radial direction. You will apply the load with the help of the UTM machine. After that, what happens? This cube will be broken into two halves. Sorry, this cylinder will broken into, I have drawn in the three-dimensional figure. Okay, now you see, this cylinder is broken into two pieces. Now this is one half, this is one half, and the second one. So what type of the forces are applied here? Up to some extent, the compressive nature force is applied. After that, it will went to the tensile. So the strain curve, this is the tensile nature. So that's why it is called the split tensile force or the tensile strength. Split tensile force, or you can say split tensile strength. Normally, this is accepted by the BIS code. In India, there is no such arrangement in the UTM and CTM machinery. That's why generally we will go for the split tensile strength. But this is not true. This is exactly not the tensile strength you are measuring. Only this is the splitting. The cylinder you are splitted in the longitudinal direction. That's why it is called the split tensile strength. For example, on an average, for a cube of M30 grade concrete, what is the compressive strength normally? The compressive strength is 32 Newton per mm square, for example. Okay, for example, 32 Newton per mm square. So if you go to the split tensile strength, approximately 32 divided by 10. That means 3.2 Newton per mm square. Generally, concrete is very weak in tension. That means concrete is very strong in compression, but weak in, that means very weak in tension. That's why we are providing the steel rods in the tension zone. What about the flexural? That means in case of the flexural strength, that means 0.7 times of the root FCK. FCK means that is 32 Newton per mm square. Because what is the compressive strength? As I told to you, this is the 32 Newton per mm square, because the M30 grade concrete, for example, in the cube, I got the 32 Newton per mm square. So 32 under square root 0.7. Approximately, this will gives you around 7.6 Newton per mm square. Am I right? So now you see, approximately the compressive strength is 32 and split tensile is 3.2 and flexural is 7.2. Okay, this is normal. That means if you take the tested around the 1000 cubes data or 1000 cylinders data, normally you will get that. Now there is a relation between the compressive strength and the tensile strength. Now you see, that means obviously it is a concavity upward curve. That means they are tested lot of samples. Out of that, they have drawn a best fit curve. That means the R square value is very minimum value. That means 0.99 best fit they have done. And now you see this thick line indicates that this is the tensile strength and compressive strength relation. That means what relation it has? While increasing the compressive strength, the tensile strength also correspondingly increases. Next, third property is durability property. Very, very important. Durability, I would like to ask you one question in the examination. Durability aspect is very, very important nowadays, because the building, you want to construct a building, your expectation is at least the building life is more than 50 years. So the building should not disintegrate before the 50 years. Normally, in the Britishers' time, whatever the structures they have made, around 100 years they have planned. But as normal, we are planning that 50 years your building should not be damaged. Your building infrastructure. Maybe that is a bridge, maybe that is a silo, maybe that is a chimney, that is a high-rise building, whatever it may be. What is meant by durability? First of all, I would like to give in the durability definition. The durability of concrete can be defined its resistance to deteriorating influences, which may reside inside the concrete itself or external itself. Suppose the damaging components may present in the concrete itself, or the damaging agents may present in the external atmosphere. Sometimes That durability means what? Suppose you are placed the concrete column. For example, this is my column. Okay, this is a concrete column. This is my building, and this is my concrete column. This column will be damaged after 20 years. I have expected 50 years life of this column, but it is damaged within the 20 years. That means what is going on? That means some influencing agencies. That means some deteriorating agencies. That means deteriorating agencies available in the concrete itself. Suppose the concrete itself some deteriorating. Sometimes because of the external environment. That means some agents are available in the external environment. Now, for example, I will give you one example. Suppose in the nearby JP College, Sika also well aware of that. Suppose we are having the two companies. One is GAIL. GAIL means Gas Authority of India, and the second one is National Fertilizers. Okay, two companies are nearby, very nearby, 5 to 10 kilometers range. Suppose if you go to the GAIL plant, GAIL matlab hai Gas Authority of India, and a government plant. There, all the buildings are very safe and very beautifully nowadays. If you go to GAIL and NFL are constructed in the year 1984. Indira Gandhi was laid down in the foundation stone in the same day. Okay, GAIL and NFL foundation stone was laid down in the same day. But now you go to the GAIL and if you visit the NFL campus, now you will observe one thing. The GAIL structural members are nowadays also it is very durable components and very safe and beautifully looking. But if you go to the NFL, all the buildings are very dirty nature. That means dirty in the sense, my sense of the observation is all the roof slabs are falling down and they are bulging and the reinforcement is visible from outside and the roof slabs are falling and the expansion is happened and the walls also, the top cover will be falling down continuously. That means that is already damaged structures, even though residential campuses or whatever it may be. Ah, ah, मिल गए मिल गए हाँ 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 करेक्ट है जल्दी जल्दी पॉइंट पे आइए हाँ ओके हाँ नहीं जरूरत नहीं है मतलब क्योंकि समथिंग एवरीथिंग इज ओके कार्ड मिल गया है मतलब नहीं नहीं चाहिए कार्ड कट गया तो आप डिलीट कर देना मतलब जो चार्जेस का नहीं मेरे को नहीं चाहिए वो जो भी नहीं चाहिए आप डोंट कॉल मी डोंट कॉल मी हाँ ओके सॉरी फॉर द इंटरप्ट okay now come to the once again here. Suppose the agencies are sometimes they will present in the concrete itself. Suppose the external agencies and internal agencies both may damage the concrete more probably nowadays because some agencies are present in the concrete itself and we can't avoid suppose in our body also some poisonous materials also there. Suppose our organic system is also having some inside some components, they will damage our body. Suppose some external agencies, that means flu virus, etc., and cough and fever, etc. These also external agencies. So similar way, the concrete is also having the causing damage with the two agencies. One is internal agencies and external agencies. Okay. Nature of the problem. That means what are the various natures of the problem for the deterioration. That means the main deteriorating agencies are two types. One is mechanical and the second one is chemical. But mechanical agencies are externally visible and we can control these agencies. Suppose this abrasion, erosion and cavitation impact, temperature is under our control. Suppose if you see in the gate, the spillway gate of the Nagarjuna Sagar project, for example, I will say that means this is the spillway. This is the spillway gate of the Nagarjuna Sagar or Free Salem project or Sardar Sarovar project. This is a dam. Okay. Suppose if I am releasing the water, what happens? A tremendous water currents are generated, and so that the top surface of the downstream side. This is the downstream side. This top surface may be eroded because of the heavy currents. That means because of the heavy currents of the water currents, what happens? The top surface of the concrete material will be eroded. This is nothing but your mechanical action, abrasion, rubbing. That means because of this water and this concrete surface is lot of friction will be generated, because this dam height is 200 meters, a very height structure. So in case of the flood time, the lot of water is coming with a tremendous electric, the tremendous currents, wave currents. So this top surface may be aware. So this is also deterioration. Deterioration means what? The damaging of my structure, this concrete structure. But what type of erosion is there? This is the external agency. This is the external agency damage. That means maybe abrasion, maybe erosion, maybe in case of the piers. Suppose this is a long bridge. Suppose the water is flowing at a Parvati river, is a very tremendous speed. What happens? This pier material nearby this surrounding soil material and surrounding material, bed material will be washed along with the water because of the heavy flow, because of the high flow. In case of the rivers in the especially flooded season, what happens? The top surface of the material will be eroded. So this type of the agencies comes under the mechanical agencies. These cavities are formed, eddies are formed, lot of impact. Suppose sometimes what is going on? Suppose this is my concrete material. Suppose this is my member. Some very heavy load is dropping, because on the concrete floor, I am dropping a 50 kg weight material from a 1 or 2 meter height. Suppose I am dropping a one big stone, that means 20 kg, 10 kg stone is I am dropping. That means I am applying a impact load, that is the external damaging factor. Because of the dropping of the heavy weight, my concrete slab is broken into small pieces and deterioration is started. These activities will come under the external agencies or mechanical agencies. But nowadays we don't talk much about the mechanical agency, because this is the physically we can control, but we can't control nowadays is these chemical agencies. These are very, very dangerous, and these are not visible to your eyesight. So we can't control them because of these reasons, this sulfate attack, chloride attack, and carbonation, and this hungry water. Because of these agencies, the concrete members are damaging widely. So we have, as an engineer, concrete specialist, we have to thoroughly focus on the chemical agencies rather than mechanical agencies. Chemical agencies are what? The various deteriorating agencies are the sulfates, that means sulfate attack. Chlorides, that means chloride attack. Concrete will be chloride attack will be started. Next is CO2. CO2 means carbonation will started. That means that means one day, one beautiful day, that means the entire structure will be collapsed, because all the concrete member is attacked by the sulfates and chlorides and carbonation and the natural ingress water. That means very hungry water. Some waters also they will attack the concrete and they will damage the structures. So the chemical and the mechanical agencies are given in this slide. Next, effects of the chemical agencies. The chemical agencies, the first effect is effect on the cement paste. That means the entire concrete member is having some phases. In the concrete member, what are the various phases available? Suppose this is my beam, concrete beam. Okay. What are the various phases? That means this is my concrete beam. Suppose first one is reinforcement. This is the reinforcement. Okay. Reinforcement. That means my external members will attack on the reinforcement rods. That means steel rods. And the second one is, this is aggregates. Aggregates. That means some agencies will attack on the aggregates also. Aggregates also they will attack. That means aggregate will be disintegrated. Alkalis, etc. Whatever the materials in the silica, that means K2O and Na2O. These two are called the alkalis. They are generally present in the cement. Okay, this is 0.6% alkalis. These alkalis are attacked on the aggregates especially. So ASR problem, that means alkali silica reaction will start, and the aggregates will be eaten away by the this alkali. Suppose if you see the wooden material, some insects will eat in the cart, and that means doors and this windows, etc. Now you see a white color terminates, that means termites will eat in that wooden material. Now one beautiful day your door and windows and your cart will be damaged. So similarly, what they will do, that insects or termites will eat in the wooden material. In similar way, this alkalis will eat in this aggregates. So this is alkali silica reaction. But luckily in India we don't have that alkali silica reaction type aggregate. That means reactive silica. If in the aggregate contain the reactive type silica, that means the aggregate means majority of the portion is silica, na? SiO2, silica. In the aggregate, the majority portion is silica. Suppose in this alkalis react with this silica, then what happens? One day this size aggregate, next day what happens? It will reduces to this size, and next day it will reduces to this size, and one day next day. That means what is going on? That means this alkalis is started the reaction on the this silica portion, and the silica is disintegrated day by day, and the one day the aggregate portion will be disappears. Okay. Next, another phase is cement paste. This is the cement paste. Okay, na? This is called the cement paste. Okay, now these are the various phases. Okay, now come back to this slide. That means first agencies, which agency attack on the which type of the phase. That means effect of the cement paste. Cement paste ke upar hai, that means sulfates will attack, carbonation, that means carbon dioxide will attack, and chloride salts will attack, and hungry water is also attacked. That means paste will be damaged. Suppose in that beam member or column member or the slab member, the paste is completely damaged due to the sulfates, due to the carbon dioxide, due to the chloride salts, and hungry water. Hungry water मतलब some reactive type water. That means इसको बोलते हैं मतलब heavy water, etc. Next, effects on the reinforcement. Reinforcement also, the steel rods, whatever the steel rods you are provided, 10 mm, 12 mm, 15 mm, 20 mm rods, those rods also corroded. So effects on the aggregate. That means in the cement you are having the silica, that means alkali content. That alkali content also attacked on the aggregates, and the damage will be taken place. Effects on the concrete. The entire concrete, that means expansion. Expansion means the beam member or column member be bulged. Bulged मतलब है आज 200 mm का जो column है, tomorrow हो जाएगा 300 mm. उसका मतलब है bulge हो जाएगा, मतलब बहुत बड़ा मोटा होता जाएगा, मतलब लीचिंग हो जाएगा. लीचिंग मतलब है ऊपर से नीचे white patches जैसा आके, मतलब नीचे slab है, मतलब छत है, मतलब नीचे गिरता रहेगा. Cracks and loss of the strength. These are the entire concrete के ऊपर effects है. Next, structures likely to be affected. What are the various structures likely to be? Abrasion, pavements. Concrete pavement, generally what happens here? Suppose in case of the road rollers and military tankers and steel wheeled bullock carts are going on the road. Some bullock carts are provided with a steel surfaced wheels. Some bullock carts. If the bullock cart is provided with the steel ring is there, at the outer surface of the wheels of the bullock cart, what happens? Because of that, pavement will be abraded. That means it is eroded. And factory floors, in case of the factory floors, if you are dragging the machinery, if you are dragging the heavy loaded items, then what happens? The mechanically they are eroded. That means rubbing action will be, friction action will be started. Spillways, in case of the, if I am opening the gate of the Nagarjuna Sagar, Sardar Sarovar and Sri Salem or any dam, then tremendous speed of the water currents will be damage my top surface of the downstream side. And the temperature gradient, sometimes in case of the some season, suppose daytime is very hot sun and nighttime a very chilled temperature, because temperature gradient, that means alternative thawing and wetting, alternative high temperature and low temperature, high temperature, low temperature. So because of this mass concreting, these are the various problems may arises in case of the mechanical damages. And chemical, that means corrosion of the steel. The steel rods will be corrosion. That means yellow color precipitate will be formed on the steel rods. So if the corrosion is started, the steel rods, the life of the steel rod is damaged, then obviously the tension zone concrete should not take the tensile forces. So your slab will be collapsed one day. Next, carbonation. Because of the carbon dioxide present in the atmosphere, this will react on the calcium hydroxide and forms the calcium carbonate. So then because of this, RCC members and pre-stressed carbonation, the pre-stressed members, carbonation will be normal problem. The sulfate salts and chloride salts and marine constructions, marine means समुद्र में, जो समुद्र में बॉम्बे एंड विशाखापट्टनम है ना, कलकत्ता एक्सेट्रा सी शोर में, दिस मैराइन कंस्ट्रक्शंस में, दिस सल्फेट साल्ट्स जनरली अटैक ऑन द मेंबर्स ऑफ द piers, jetties, suppose in case of the harbor structures, and ASR, hydraulic structures and bridges में ASR problem. Next, mechanism of attack. That means most of the questions you may get it in the mechanism of attack. What type of the mechanism and how it will attack on the concrete structure. You have to thoroughly follow these mechanisms of the attack because you are a research students. So you have to thoroughly go ahead with the mechanisms, basic mechanisms very thoroughly. Okay. First, sulfate attack. Sulfate attack, that means sulfo-aluminates, that means ettringite. That means this C3A, CS3, H32. This is called the product of the ettringite. This ettringite will be formed while the sulfate salts are presented in the attack on the C3A component. That means in the box compound, that C3A, tricalcium aluminate, reacts with the sulfate salts and forms the ettringite. Once the ettringite is formed means the increase of the volume will take place and the expansion and the spalling of the concrete slab will be happen. Suppose this is the roof slab. For example, this is the roof slab. Suppose if the C3A content will forms with the added with the sulfate salts, that means sulfate salts, then what happens? Ettringite will form. Ettringite will be formed. If the ettringite form ho gaya, what is the initial thickness of the concrete slab? The initial thickness of the concrete slab is 120 mm. The concrete slab ka jo bhi thickness hai 120 mm. Once the this sulfate salts are attacked on this concrete slab because of the ettringite, this 120 slab hai tomorrow morning tak hai, that means 140 mm हो जाएगा, bulging हो जाएगा, मतलब ऐसा वाइड हो जाएगा. उसका मतलब क्या है? व्हाट इज दैट? मींस बल्जिंग. दैट मींस ये एनलार्जमेंट हो जाएगा. एनलार्जमेंट होने के बाद फिर वंस अगेन दिस कंक्रीट स्लैब विल बी फॉल डाउन ऑन द फ्लोर्स. दैट मींस दिस इज द रूफ स्लैब. Then one day this concrete slab will be fall down and the thickness of the slab will be day by day, it will be reduced. So this is the sulfate attack. Okay. Now once again, the second, this formation of the calcium sulfate. Calcium sulfate, other name is gypsum. So the gypsum reaction with the lime. That means lime matlab CaO plus H2O. This lime, that means they are lime are formed by the hydration of the cement. In the hydration process, this NS plus CH. That CH means lime. This NS matlab is the sulfates, the sulfate salts. That is nothing but your gypsum. If 2H, H matlab H2O, gives rise to the CSH2 plus this NH. Formation of this calcium sulfate, this NH will formation also increase the volume of the expansion and is falling of the slabs and beams and columns. That beams and columns and slabs also bulges. Once one day beautifully they are collapsed. Okay. Next, magnesium sulfates is more aggressive than the sodium and calcium salt. Normally क्या है, this magnesium sulfates are available in the atmosphere or in case of the marine environment, they are more dangerous than the sodium and calcium salts. अगर calcium salt है, sodium salts है, your structure will be safe up to at least 20 to 30 years. अगर if in your structure is attacked by the magnesium sulfates within the 10 to 15 years, your building will be collapsed because these magnesium sulfates are most dangerous than the sodium and calcium salts. And now you see this is a carbonation. Carbonation means this is a just a red color concrete is happened. Now you see that means this concrete this cylinder is attacked by the carbon dioxide. Because of this, carbon dioxide is attacked from the external agency in the atmosphere. In the atmosphere, you have the oxygen, carbon dioxide, and nitrogen. This carbon dioxide is damages this concrete, but carbonation is also happened. Now you see next carbonation. How the this carbon dioxide, CO2. This carbon dioxide is react with this calcium hydroxide phase and formation of the calcium carbonate. That means CaCO3. That means the main concern of the reaction of the carbon dioxide with the lime phase and it give the calcium carbonate. Therefore, now ये carbon dioxide है, it will attack on the Ca carbon hydroxide phase में attack करेगा, फिर calcium carbonate plus water कर. Sometimes this carbon dioxide not only attack on this calcium hydroxide, it will attack on the CSH gel. CSH gel is already, it is the strength phase. Actually, you know that better than me. That means while in the hydration process, do you understand that, for example, C3S plus H2O gives rise to CSH gel. This is the strength phase plus calcium hydroxide. Actually, you know this is basic equation. Okay, na? In this, this is the strength. That is the strength phase. That means this is the strength phase. This is the waste. This is the waste. Generally, ये carbon dioxide है, इसी के ऊपर attack करेगा. This carbon dioxide attack करके, that means now it will form the calcium carbonate. That means CaCO3 formation. Sometimes इसको छोड़ के ये strength phase also it will attack. तो अगर इसके ऊपर अटैक हो गया है, देन आपका जो बिल्डिंग है मतलब जल्दी कोलैप्स हो जाएगा. In all such reactions, OH ions are consumed, thus the lowering down the pH. अगर कंक्रीट के अंदर है pH is lower हो गया, that means किस में चले जाएगा? That means if the concrete में pH down हो गया, concrete will go into the acidic medium. Suppose you know that for Sorensic scale, suppose this 7 is neutral water. That means water is under neutral. Suppose 0 से लेके 7 तक है, this is the acidic medium. Okay, 7 to 14 है basic medium. अगर concrete है base medium में है, then no problem. Reinforcement है, safe रहेगा. अगर आपका pH है, concrete के अंदर pH है, down हो गया, then ये concrete है, मतलब reinforcement है, मतलब acidic medium में, मतलब corrosion जल्दी start हो जाएगा. Corrosion है, that means ये reinforcement है, damage हो जाएगा. Reinforcement damage हो गया तो beam है, collapse हो जाएगा. So always है, बेसिक नेचर में होना चाहिए. क्यों ये एसिडिक मीडियम में प्रोवाइड हो गया? बिकॉज ऑफ द OH ions are consumed in case of the carbon dioxide. In case of the carbon dioxide, OH ions are consumed because then it will went to the pH is went to the lower side. When the pH is lower side, the reinforcement will be damaged. Now you see, in case of the alkali silica reaction, that means alkali silica. Now you see this white color patches. That means these aggregates also eaten by the alkalis. That means in the layman language, I am saying that they are eaten, they are reacted with the aggregate silica. That means the silica content is more in the aggregates. Their alkalis are generally attack on the that reactive silica. Okay, so the aggregates will be disintegrated or damaged beautifully on one day. Okay, now you see this white color patches. This is nothing but your ASR problem. But luckily in India, we are having the granite stones. All the sources, parent stones is granite sources. So granite rock generally don't attacked by the alkalis. So we don't have that such much problem in the through the alkalis. Only cold countries, some other countries having the ASR problems much. Okay, ASR problem. That means this granite and gneiss and schist and quartzite, sandstone, generally we are using for the India. Okay, these chemical reactions between the aggregates and alkalis. Alkalis matlab hai K2O and potassium. That means Na2O and K2O. That means these potassium salts and sodium salts are called the alkalis, which are generally we are added in the cement. These are reacted with the reactive type silica, which is available in the some type of the aggregate, aggregates, coarse aggregate. If there are reactive type, this ASR problems will be generally present. Okay. Now you see corrosion of the steel reinforcement in the concrete structures. Now you see the steel bars. Now you steel bars are visible from the external ice. What is the reason? Maybe because of the, that means whatever the cover, the 25 mm cover is provided, that cover is fallen down. That means it is fall down. That means the cover is removed. Then the reinforcement is exposed to the environment. One day what happens, after 2-3 years, this atmosphere is having the some humidity, moisture content. That means humidity means moisture content present in the atmosphere. Because of the moisture content, because of the oxygen. If these two are present in the atmosphere, this reinforcement is exposed to that oxygen and water content, then yellow color precipitate will be present on the top surface periphery of the reinforcement. That means the iron rod is subjected to corrosion. So one day these iron rods will be disintegrated. Once the iron is disintegrated, the concrete should not take these tensile forces in the bottom area. You know that neutral axis, na? Suppose top members are subjected to compression and bottom members are subjected to tension. In case of the tension zone, the reinforcement is damaged, then this bridge deck will be collapsed. So this is the corrosion problem. The corrosion is happened in case of two items presence. That means the corrosion is take place when the two items are present. Please remember that, very very important point बता रहा हूं. ऑक्सीजन एंड मॉइस्चर कंटेंट, अगर ये दोनों है तभी करोजन लगेगा. अगर मान लीजिए ये दोनों में एक भी एब्सेंट है, वन इज एब्सेंट, करोजन नहीं होगा. मान लीजिए ये एटमॉस्फेयर में ऑक्सीजन नहीं है, तब करोजन नहीं होगा. ये एटमॉस्फेयर में मान लीजिए वाटर कंटेंट मतलब है छोटा छोटा ड्रॉपलेट्स, मॉइस्चर, दैट मींस फॉग मिस्ट रहती है ना ठंडी मौसम में, देखो ये सब फॉग मिस्ट जो भी मॉइस्चर ड्रॉपलेट है, वो मॉइस्चर ड्रॉपलेट नहीं है, तब सरिया को कुछ नहीं होगा. जो भी सरिया को जंग लगने के लिए दो ही रीजंस है, ऑक्सीजन भी होना चाहिए एंड एटमॉस्फेयर में मॉइस्चर कंटेंट भी होना चाहिए. इसलिए मान लीजिए एक सरिया को आपने समुद्र के अंदर फेंको, दैट मींस यू विल थ्रो ए आयरन रॉड अंडर द वाटर ऑफ द ओशन. समुद्र के अंडर में फेंको, 10 साल के बाद निकालो सरिया को, कुछ नहीं होगा. क्यों? एट द बॉटम लेयर्स ऑफ द वाटर अंडर द सी देयर इज नो ऑक्सीजन. ऑक्सीजन है मिलेगा नहीं है. दैट मींस एट ए ग्रेटर डेप्थ ऑफ द ओशन वाटर, समुद्र के अंदर है, सबसे बॉटम डेप्थ में ऑक्सीजन है अवेलेबल नहीं है, बट पानी है, वाटर कंटेंट इज अवेलेबल फॉर द आयरन रॉड, बट ऑक्सीजन कंटेंट नहीं है. But corrosion may take place when the oxygen and water moisture content both will be available to the iron rod or steel rod. Then only the corrosion will take place. This is the beauty of the corrosion. अगर corrosion के लिए आपके पास है moisture content भी होना चाहिए, oxygen भी होना चाहिए. सरिया को एक काम करिए, you do one, take a rod and paint it beautifully, a thick paint कर दो ना, मतलब उसको जंग नहीं लगेगा. क्यों? Because मतलब you are taking a preventive coat to the moisture entry. That means moisture entry and oxygen entry के लिए you are prevented with a tack proof coat. That means एक resistive layer है provide कर रहा है, समझेंगे ना. Then सरिया को corrosion नहीं लगेगा. Now okay. Now corrosion of the reinforcement. Corrosion very very important. I may ask you one question in the corrosion. Corrosion के लिए anodic reaction and cathodic reaction. Iron means ferrous. Ferrous material is called the iron material. So ferrous is divided into, that means metallic iron is divided into 2E minus plus ferrous 2 plus ions. That means in the anode, the ferrous is divided into E minus ions and 2 plus E ions. Next, this cathode, at the cathodic reaction, that means oxygen, that means 1/2 of the oxygen plus water. And they are reacted with this E ions. That means whatever this ferrous material is split into positive and negative ions, na? That means this is E plus ions and E minus ions. These oxygen and this water component will react or attack with the this E minus ions, and 2H OH ions will be formed. That means this will be converted. That means oxygen and water, and this 2E is converted as OH ions. These hydroxyl ions, these hydroxide ions, this means these are very dangerous. Now you see, this ferrous material plus of oxygen plus water gives rise to Fe2 plus plus 2OH minus ions. This is nothing but iron hydroxide. This OH minus ions is combined with this Fe2 plus ions will gives rise to rust. That is nothing but yellow color precipitate. Okay, now you see, here you go. This is anode. Okay, this iron rod is having the anode and cathode. Okay, anodic reaction में देखता हूँ. Now you see, at the anode, this Fe plus plus, that means Fe2 plus लिख देता हूँ. I will write it as Fe plus plus means I will write Fe2 plus. And now you see, at the cathode के पास है, देखो E minus ions will be formed. That means ferrous is split into E minus ions and Fe2 plus ions. Am I right? That means ferrous is Fe is divided into E minus plus Fe2 plus ions. And once again, now you see, this E minus ions always react with the water content in the atmosphere. पानी के अंदर मतलब एटमॉस्फेयर में कुछ ह्यूमिडिटी रहती है ना. ह्यूमिडिटी मतलब है सरफेस में. दैट मीन्स एटमॉस्फेयर में थोड़ा वाटर कंटेंट तो रहेगा. रेनी सीजन में देखो, winter season में देखो. Now you will look into the winter season and rainy season, you will get lot of humidity. That means water droplets. So that water droplets and oxygen, atmosphere is always contains with the oxygen. This oxygen and this water will combine with this E minus ions at the cathode. At the cathode के पास है जो E minus ions है, ये H2O and oxygen के साथ मिलके ये OH ions को फॉर्मेशन करती है. समझने के लिए कोशिश करो. ऑक्सीजन एंड वाटर है, ये E माइनस आयंस के ऊपर है, अटैक करके OH आयंस है फॉर्मेशन करते हैं. ये OH आयंस क्या करती है, जो भी फेरस मटेरियल है दो में डिवाइड हो गए ना, वन इज E माइनस एंड वन इज Fe प्लस. ये OH आयंस है, एरो हेड. वंस अगेन ये OH आयंस है, ये Fe के ऊपर है, Fe2 प्लस के ऊपर है, कंबाइन हो जाएगा FeOH ट्वाइस. दिस इज नथिंग बट योर रस्ट, येलो कलर प्रेसिपिटेट. So the anode Fe plus react with the OH minus ions and formation of the rust. And in the cathodic reaction, this water and oxygen react with the E minus ions and the formation of the OH ions. Now इसी को वापस चलो देखो. This anodic reaction क्या है, Fe2 plus formation होती है. That means E minus ions plus Fe2 plus. ये दोनों मिलके Fe है. So Fe is splitted into at the anode 2E minus plus 2E2 plus. And at the cathode के पास है, this 2E is combined with oxygen and water and formed the OH ions. This OH ions, ध्यान से सुनो, this OH ions already combined with this Fe2 plus. जो भी इधर मेरा कर्सर फॉलो करो, Fe2 प्लस आयंस के पास है, ये OH आयंस है, ये दोनों कंबाइन करके फॉर्म होती है FeOH ट्वाइस. दिस इज नथिंग बट योर रस्ट. ये इक्वेशंस है, क्लास के बाद दोबारा पढ़ लीजिए. Ingress of the corrosive species into the porous concrete. If the concrete is cracks and it is very pervious material, then the external agency means what? Oxygen and water. एटमॉस्फेयर में जो भी ऑक्सीजन है, वाटर है, जो ये क्रैक के द्वारा ये सरिया के ऊपर पहुंच जाते हैं. अगर मान लीजिए कंप्लीटली सरिया है, कंक्रीट का इनसाइड में है, नथिंग विल हैपन. बट ओनली द थिंग इज, आपका जो बिकॉज ऑफ दिस कैविटीज, बिकॉज ऑफ दिस क्रैक्स, दिस एटमॉस्फेयर में जो भी ऑक्सीजन है, एटमॉस्फेयर में जो भी मॉइस्चर कंटेंट है, ये सरिया के ऊपर है चले जाती है. सरिया के पास क्या करती है, that means Fe, iron is divided into Fe plus plus and A and D and 2E minus. ये 2E minus आयंस क्या करती है, ये जो भी ऑक्सीजन है बाहर से आ गया, इसी को पकड़ लेता है. सो आप है OH आयंस फॉर्मेशन होता है. जो भी ये OH आयंस फॉर्मेशन हो गया, ये OH आयंस है, वो जो पहले फॉर्मेशन हो गया ना Fe प्लस प्लस, उसके ऊपर कंबाइन करके मतलब ये रस्ट. दैट मीन्स ये cracking and spalling of the concrete cover and built up of the voluminous corrosion product. That means ये corrosion, ये सरिया क्या हो गया, ये 12 mm रॉड है, कल तक है 15 mm, कल तक है 20 mm. उसका मतलब क्या है, ये रॉड है बल्जिंग हो जाएगा, मतलब स्वेलिंग हो जाएगा. आपको फोड़ा फुंसी आ गया, मतलब ये फोड़ा आ गया, तब देखो मतलब बाल तोड़ आ गया, उस समय देखो आपका बॉडी से फस बाहर आएगा ना. सिमिलरली ये करोडेड मटेरियल है, येलो कलर करोडेड मटेरियल है, सरिया एनलार्जमेंट हो जाएगा. सरिया के अंदर है जो Fe415 स्टील है, 415 न्यूटन पर mm स्क्वायर स्ट्रेंथ नहीं रहेगा. सो दैट कॉन्क्रीट स्लैब है मतलब डैमेज हो जाएगा. मेन रीजन फॉर करोजन. करोजन के लिए मेन रीजंस क्या है? व्हाट इज द मेन रीजंस? द मेन रीजन इज एंट्री ऑफ द ऑक्सीजन, एंट्री ऑफ द मॉइस्चर कंटेंट. ओके, ओके, ये दोनों एंट्री कब होगा? व्हेन द कंक्रीट इज हैविंग सम गैप, द कंक्रीट इज हैविंग सम क्रैक. अगर आपने कवर प्रोवाइड कर रहा है बढ़िया से 30 mm और 40 mm कवर प्रोवाइड कर रहा है, मिनिमम 25 mm कवर, मतलब वो क्लियर कवर प्रोवाइड कर रहा है. अगर आपका कवर इज ब्यूटीफुली thick and dense cover, nothing will happen to the reinforcement. But the problem is your cover में कुछ डैमेज है, दैट मीन्स कुछ एंट्री है, मतलब कैविटीज है, आपका वाटर सीमेंट रेशियो ज्यादा यूज किया, पानी है एवापरेट हो गया, जो भी कैविटी बचेगा वो कैविटी के पास हवा चले जाएगा. हवा में क्या है? ऑक्सीजन है. मॉइस्चर, दैट मीन्स एटमॉस्फेयर में मॉइस्चर कंटेंट रहेगा, ये मॉइस्चर कंटेंट भी रहेगा. सो द रीजंस आर presence of the chloride ions, poor quality of the concrete, and high permeability, no control of the water ratio, and the pH value, low pH value, उसका मतलब मीडियम में चले गया. That means they OH ion consumption हो गया, OH ion consumption हो गया. That means this medium से will the pH ion. Then carbon means then the pH में carbon हो जाएगा. So because the reason okay, I will start this. One more in the